Hello, good day, grade 11 STEM students. Welcome to our new episode in Basic Calculus class. I am Teacher Raymond and I am your math teacher for today. Up to this point in calculus, you have been concerned primarily with these problems. Given a function, find its derivative. Many important applications of calculus involve the inverse problem. Given the derivative of a function, find the function. So before we go through to our discussion, let us have first the objective of today's lesson. At the end of this lesson, we should be able to compute the general antiderivative of polynomial function.
I know that you are all excited, so let's get started. Anti-differentiation. When we say anti-differentiation, then that is the process or operation that reverses differentiation. So meaning, anti-differentiation here is the reverse operation of your differentiation operation. And to understand clearly and visualize what is the relationship between anti-differentiation and differentiation, so let us have an example here. So example, what is the antiderivative of 2x? So if you're asked to find the antiderivative of 2x, then that is equal to x squared plus c. But if you're going to get the derivative of x squared plus c, where c is any constant, then it will go back to 2x. Okay, using power rule, the derivative of x squared plus c is equal to 2x. So as you can see, this is the relationship between antiderivative and derivative. Okay, so consider the following function. Find its derivative. So in number 1, we have y is equal to x squared, followed by y is equal to x squared plus 1. Then we have y is equal to x squared plus 2. Fourth, we have y is equal to x squared plus 3, and lastly we have y is equal to x squared plus 4. If we're going to get the derivative of the 5 function, then it will give us a result of y prime is equal to 2x. That is the derivative of this 5 function, because using power rule, okay, the derivative of x squared is 2x and the derivative of any constant is equal to 0. That's the reason why we have here y prime is equal to 2x. And if we're going to get the antiderivative of the function that we derive, then the answer is y is equal to x squared plus c. So as you can see, I add c here. So why? So the idea here is, if a function has an antiderivative, then it has an infinite number of antiderivatives. So therefore, if we're going to get the antiderivative of this, it will gives us an infinite number of antiderivatives. So that is the reason why we add here plus c. So to capture the fact that there are infinitely many antiderivatives, we add a constant, and that constant is called the constant of integration. So now let us talk about antiderivative notation. So it says here that the anti-differentiation process is also called integration. So if you are asked to integrate, then it simply means that you are getting the antiderivative, or yes, the antiderivative of a function. So here, that is our integral sign. And then the fx here, the function, is the integrand. Your dx is the differential or the variable of integration. And then the answer is f of x, uppercase fx, that is the antiderivative of a function fx. So if we're going to get the derivative of this, then it will give us f of x. Okay? So f prime of x is equal to small letter f of x. So basic integration rules. We have here the antiderivative of a number dx. So how are we going to answer this kind of problem. So the derivative. So to answer this, we have the number times x plus c. Don't forget to write plus c in your final answer, because if a number or if a function has an antiderivative, then it has infinite number of antiderivatives. So, for example, evaluate this, the antiderivative of 2dx. So our answer is, we're going to copy the number. So that is 2x, multiply that by x, so 2x and then plus c as our final answer. So that rule is called the constant rule for integration. So if you are asked to find the integral of the constant or c, any constant number dx, then that is constant times x, okay, plus c. So evaluate, what is the integral of negative 5 dx? So our answer is, copy negative 5, multiply that by x, because here we have x variable. So negative 5x plus c. So negative 5x plus c. And then if or in our derivative, we have the power rule for differentiation. Here in antiderivative, we have the power rule for integration. So suppose that you are asked to find the antiderivative of x raised to n. So all you have to do is to add 1 to your exponent. So n plus 1. So we have x raised to n plus 1. And then copy the whole exponent and make that as your denominator. So we have n plus 1 as your denominator. Given that your n is not equal to negative 1. But if your n is equal to negative 1, then we can rewrite that. Okay? If your n is equal to negative 1, then x raised to n, we could have x raised to negative 1, and x raised to negative 1, we could rewrite that as 1 over x. And the antiderivative of 1 over x is this, ln, the absolute value of ln of x. Okay? So this absolute value prevents you from having to find the natural log of negative number. So this rule is called the power rule for integration. Next, so what if we have here the number times any function dx? So what if you are asked to find the integral of a number times a function? So to answer that, all you have to do is to pull out the number. So you pull out the number. So we have number and then get the antiderivative of f of x. Okay, so the integral of a function times a constant is equal to the constant times the integral of a function. And we have here a warning. You cannot pull out variables, just constant. So, like for example, you're asked to evaluate the integral of 5x cubed dx. So all you need to do is to pull out 5. So let me copy that here. Antiderivative of 5x cubed dx. So you have to pull out 5. So we have 5 and then get the antiderivative of x cubed dx. So using this rule, no, the power rule for integration, we have 5 times, we add 1 to the exponent. So x raised to 3 plus 1 and then 3 plus 1 as your denominator. So 3 plus 1 plus c. Don't forget to write that. So that is equal now to 5 and then x. 3 plus 1 is 4 over 4 plus c. So let us find out if our answer is correct. So, okay, so we have 5 over 4 x raised to 4 plus c. Okay, so the question here is, how are we going to determine, or how do you know if you have found the correct antiderivative? So the answer is take the derivative of your answer to check. So if we're going to check, no, if we come up with our we come up with the correct answer. So let us get the derivative of this. So we have 5 over 4 x raised to 4 plus c. So if we're going to get the derivative of this, so let's say that this is our f. Okay, so f prime now is equal to 5 times 4, that is 20. Okay, x 4 minus 1 is 3 over 4. The derivative of any constant is 0. So f prime now is equal to 20 divided by 4 is 5x cubed, which is this. So meaning, we get the correct, or we got the correct answer. Next. So that rule is also called the constant multiple rule for integration. So if we have the constant c times a function dx, then all you have to do is to pull out c and then get the antiderivative of f of x. So that's why we have this. Here in integration, or here in antiderivatives, we have also sum and difference rule for integration. So all you have to do, if we are asked to find the integral of f of x plus g of x dx, then that is equal to get the integral of this plus get the integral of this. So we have the integral of f of x dx plus the integral of g of x dx, same as in difference, or yes. So if we have or if you are asked to find the integral of f of x minus g of x dx, then that is equal to the integral of f of x dx minus the integral of g of x dx. So now let us apply here the sum and difference rule, or the different rules, no, in evaluating this. So evaluate, find the integral of 6x squared minus 4x minus 1 over x plus 1 dx. So all we need to do is to get the antiderivative of all the terms. Now, so we have 4 terms here. So we have the integral of 6x squared dx minus the integral of 4x dx minus the integral of 1 over x dx plus the integral of 1 dx. And that is also equal to, you pull out 6, okay, and then by power rule for integration, that is x cubed over 3 minus 4. So this is, we add 1 here, so that is x squared over 2 minus the integral of 1 over x is ln, okay, ln, absolute value of ln of x, and then the integral of 1 is x, and then simplify your answer. So we have 6 divided by 3 is 2, x cubed minus 4 divided by 2 is negative 2, so minus 2x squared minus ln absolute value of x plus c, or plus x plus c. So that is our final answer, or this is our final answer. So for your task, you answer the 4 problem. So first we have the integral of 3 t squared dt. Second, we have the integral of 5 du. Then next, we have the integral of 2x raised to negative 2 dx. And lastly, we have the integral of x times 3x plus 4 dx. So how are you going to answer that? Okay, so to answer the first problem, we apply here the constant multiple rule for integration. So we pull out 3 and then we integrate t squared. Okay, so that is 3 and then the integral of t squared dt. So we have 3, we add 1 to the exponent, so plus 1 here. So we have 3, and then that's the reason why we have 3 here as the denominator, plus c. 3 divided by 3 is 1, so we have t cubed plus, eliminate this, we have t cubed plus c. So we have t cubed plus c. Next, So this is the constant rule for integration. So we multiply this by u. So 5u plus c. Okay, so we have 5u plus c because the variable here is u. So we have 5u plus c. How about here in the third example? So all we need to do is to apply also the constant multiple rule. We pull out 2. Okay, and then integrate x raised to negative 2 dx. So that is equal to 2, and then negative 2 plus 1 is negative 1 over the exponent here is negative 1, so you put negative 1 as the denominator. And then since that if we are going to divide 2 divided by negative 1, that is negative 2, and then to make our variable, the exponent here positive, we put our variable in the denominator. So we have negative 2 over x. Okay, so positive 1. It has positive 1 now as its exponent, plus c. So this is now the final answer. So don't forget to write plus c. So as you could see, we have plus c, and plus c. Then lastly, evaluate x quantity, or the integral of x times 3x plus 4 dx. So all we need to do is to apply distributive property. So we're going to rewrite first our equation. So x times 3x, that is 3x squared, and x times 4, that is 4x. So we have the integral of 3x squared plus 4x dx, and then by sum and difference rule, right? So sum and difference rule for integration. So we're going to integrate this one and this one. So we have the antiderivative of 3x squared dx plus the antiderivative of 4x dx. So the answer is, we apply here the constant multiple rule as well as here. So we have x cubed plus 2x plus c as our final answer. Okay, so for conclusion, anti-differentiation is the process or operation that reverses differentiation. The anti-differentiation process is also called integration. And then, similar to differentiation, integration has a variety of rules that we need to remember, recall, and able to use.
And that's it for today's lesson. Until our next math session. This is Sir Mark signing out.